Our project is to control relative humidity with an Arduino. So first we'll talk about the purpose and objective, which was to control humidity in a room to 50%, with the humidifier being the actuator and the process variable being relative humidity. From then we'll talk about what the experimental setup was, what our first principles model was, how we collected our data and then analyzed our data, and then designed and tuned a P-only controller. This is a picture of the experimental setup. On the left is the humidifier, and then you can see the Arduino connected to a breadboard with a temperature and humidity sensor, and that's how we were able to read the temperature and humidity values into Python. This is an up-close picture of how the Arduino was connected to the sensor. And this is a picture of the room that we were controlling the humidity in for reference of the size of the room.
And for our first principles model, we related the concentration of water in the room to what was being given off by the humidifier. And we wanted to analyze how turning the humidifier on, how that impacted the relative humidity in the room. So we first performed a step test, and then we performed a doublet test because we wanted to see not only the impact when the humidifier was turned on, but also when it was turned off, which deals with the sensitivity of the humidity. And we also wanted to analyze an FOPDT model, which is a first order plus dead time model, and we wanted to optimize it to use those parameters as initial parameters for our P-only controller. And so the black line here is our optimized fit.
So then we went on to design and tune a P-only controller, and we can go ahead and show some of the code that we used to do that. So first of all, we have this Python script that is used to read in the temperature and humidity from the Arduino, and then from there it will show a readout of what the humidity is so that we can use that as our starting value with our P-only controller and demonstrate how the controller works. So we will go ahead and run this file to get the current value. This may take some time, so please have patience.
So the relative humidity in the room is 28.3%. So then we can plug that in to here. That's what we last tested it at. And we can run this.
And so while it's running, the controller will give a message to either turn on or turn off the humidifier. And that's happening no sooner than 5 seconds in between each command, so that it's realistic to the amount of time in real life if you were to turn on or turn off the humidifier.
And as you can see from this plot, it takes a little while to first meet the set point, but not an unreasonable amount, and then it maintains that set point very well over the rest of the time.
So in conclusion, we were able to design a P-only controller that can control the humidity in a room to a specific set point, and this would be useful in applications where the humidity upon startup doesn't need to immediately reach the set point, but what's more important is that the humidity is maintained at a specific percentage throughout a long duration of time. And some further testing that could go into this model is more in-depth study of how temperature is related and in what way controlling the temperature could also help to control the humidity in the room.